What if the Big Bang wasn't the first start, but just the latest restart? Imagine black holes fading, everything turning to light, and the whole universe resetting like a cosmic game. Some scientists think we can even spot marks from the last universe in the faint glow of the sky. If that's true, it changes what beginning and end even mean. Are there clues from a past universe hiding above us right now? And can we find them? You look up at the night sky and feel the air cool on your skin. Stars seem still, but the universe is racing apart at thousands of kilometers per second. We say it began 13.8 billion years ago with a bright, hot start. But what if that start was not the first? Imagine everything spreading so far that only light remains, quiet and thin, like the hush before dawn. Black holes fade bit by bit, until even they are gone. No atoms, no clocks, only smooth light that does not care about size. In that strange end, time feels soft, space has no scale. Now flip the picture. That smooth end can be shaped into a sharp beginning. Like a drumhead pulled tight, loud boom. One aeon hands the baton to the next. Our Big Bang becomes a restart, not a lone birth. You can hear the tension like a held breath, waiting to break into fire. Heat roars, particles form, and stars will rise again. Yet the sky may carry old marks, faint rings in a cold glow left over from before. If those marks are real, they whisper a thought. Endings become openings, and forever is a loop. Picture the idea like a relay race across ages. One universe runs its lap, then, at the finish line, hands off a smooth baton to the next. Scientists call it conformal cyclic cosmology, or CCC. An aeon is one full lap, from a hot, tiny start to a cold, thin end. Our aeon is about 13.8 billion years old so far and still growing. In the far future, after stars die and black holes fade, only light remains. Light has no weight, so size stops mattering. When size does not matter, the end can be stretched and reshaped without breaking, like soft taffy pulled to a point. That point acts like a clean new beginning. No crunch, no smash. Just a quiet slide from end to start. The math that shows this uses angles, not distances, like a map that keeps shapes but changes scale. You can feel the tension here. Can an ending become a start with just light to guide it? If so, our sky might still hold clues from the last lap, tiny rings in the microwave glow. Finding them would be like hearing a faint echo in a wide cave, telling us another voice spoke first. Imagine the far future like a slow, quiet winter. The sky grows darker as galaxies drift away at faster than light speed from us because of space stretching. After about 10,420 years, new stars stop forming. After 10,420 to 10,440 years, most orbits change as things fade. Heat spreads out thin, like warm breath in cold air. You can hear silence. Lonely stars burn out one by one. White dwarfs cool to black. Neutron stars wait in the dark. The night is wide and empty. Now picture only black holes and dust. They rule the scene for a long time. Hawking radiation makes each hole leak. A small hole goes first. Giant holes last the longest, up to around 10 to the 100 years. That number is a 1 with 100 zeros. Then even they whisper away into light. What remains is simple. Photons, maybe some light particles. No atoms. No clocks that tick. When mass is gone, size loses meaning. A big map and a small map can tell the same story. Angles stay, distances slip. This is the key in CCC. The end smooths out, like glass. And in that smooth end a hint waits. A new start can form. Now the kings of the late universe take the stage. Black holes. They eat light, dust, and even stars, then sit in the dark like furnaces. But they are not forever. They leak a faint glow called Hawking radiation. heat made by quantum flickers at the edge we call the horizon. Small holes are hotter and fade faster. Big holes are colder and fade slow. A hole with the mass of our sun would last about 10,067 years. Giant ones in galaxy centers could survive close to 10,100 years, a 1 with 100 zeros. The show is slow, then sudden. For eons, the hole barely shrinks. Near the end, it heats up, brightens, and vanishes in a last flash. No crack, no sound, just light rushing out. When the last hole goes, the universe holds only photons, spread thin and smooth. Entropy that was packed inside has been turned into simple radiation. No heavy clocks remain to set a scale. The sky becomes a quiet sea of waves. Angles matter, distances fade. You can feel the story bending toward a fresh start, as if the dim cinders of one age were being sifted into the spark of the next. At the end, the universe holds only light, smooth and thin like mist. No heavy things remain to set a size. A ruler means nothing when everything moves at light speed. What still matters are angles, how lines meet, how patterns keep shape. That idea is the key in CCC. Conformal means shape without scale. With that rule, math can stretch the cold, wide end so it fits a tiny, hot start. Picture a map that keeps coastlines but shrinks the whole globe to a point. Now flip the map. The point becomes our beginning. Heat suddenly roars. In the first seconds, particles form from light, then join as the soup cools. Space is small and crowded, but the pattern of angles from the last stage can still line up. No crunch is needed, only a smooth handoff where distances fade and shapes survive. You can feel the contrast, a silent sea turning into a bright storm. The handoff is not magic. It is a change of scale that matters less when nothing has mass. That is how an ending can look like a start. And if this is true, our sky may still carry a faint hello from before. Time in our world has a one-way push. Eggs break, they do not unbreak. We call this push the arrow of time, and it follows the heat as it spreads. In physics, we track it with entropy, a number that grows. Early on, right after the Big Bang, the soup was hot but very smooth with tiny bumps only 1 part in 100,000. Smooth means low entropy for gravity. Later, clumps formed, stars lit, and black holes grew. Black holes hold huge entropy, more than 1 trillion suns of disorder on a silent screen. They swallow mess and keep score on their dark horizons. In CCC, this matters. As black holes fade by Hawking glow, they pour their stored disorder back into thin light. At the far end, when only massless stuff remains, clocks fail, rulers fail, and scale no longer means anything. Without mass, the rules let shapes survive but erase sizes like a picture without a zoom bar. That trick can reset the arrow. A smooth end can match a smooth start, so a new aeon begins simple again. You can feel the tension. Do scars sneak through? Or does the next dawn rise clean? Astronomers point radio eyes at a cold glow that fills the sky. It is the cosmic microwave background, about 2.7 degrees above absolute zero, with tiny bumps only 1 part in 100,000. If a past aeon touched ours, faint marks might hide there like ripples on a still pond. One idea says giant black hole crashes from before could leave soft circles, rings where the glow is a bit smoother than around it. People have searched for neat, evenly spaced circles a few degrees wide. Some groups claimed hints. Other teams checked with better maps like Planck and said the patterns match normal noise. Another idea looks for hot dots, tiny warmer spots that could be last flashes from fading holes. Again, claims rise, tests repeat, and most results say nothing firm yet. The work needs careful math, clean data, and fair tests that try to break the guess. You can feel the suspense. If even one clear, repeatable mark appears, the story shifts. A whisper from before would become a shout. Until then, the safest read is this. The sky fits the standard picture well, but the search goes on because one true ring could change everything. Right now, the best map of the baby sky comes from Planck, WMAP, and other surveys. They measure the glow at 2.725 K and trace tiny wiggles across the whole dome. Those wiggles match the standard model called lambda CDM with cold dark matter, dark energy, and simple early bumps from inflation. Distances to galaxies, ripples in galaxy spacing, and supernova light all line up with that same story. When teams looked for neat rings or hot dots that CCC might leave, the signals faded under tougher tests. The safest read so far is no confirmed mark from a past aeon. That does not kill CCC, but it keeps it in the maybe box. Good science sets fair targets. CCC says the end of one age should pass shape, not size, into the next. That means patterns, not parts, could cross over. If such patterns exist, they must rise above noise, repeat across the sky, and agree with other data. New tools are coming, better CMB maps, sharper galaxy surveys, and tiny polarization twists called B-modes. If we see an odd pattern that the standard model cannot explain, CCC will gain ground. If we do not, the old picture stands strong. Hold two pictures in your mind and feel the contrast like warm and cold water. In one picture, the universe first grows, then shrinks, then hits a tight squeeze and bounces. Some versions talk about a slow squeeze that smooths bumps before the rebound. Others imagine two giant sheets in higher space that touch and spark a new fire. In these bounce stories, size always matters. The crunch has a scale and the bang has a scale. In the other picture, CCC, nothing crashes. The far future thins to light, black holes fade, and only massless waves remain. When no one carries weight, size stops counting. And math can slide the smooth end into a clean new start. So CCC passes along shapes, not rulers. That is why its tests look different. Bounce ideas may leave sharp scars from a squeeze, like special ripples or twists in the baby sky. CCC looks for soft rings or low spots, signs of heavy events long ago in a past aeon. Both must face the same hard judge, the data. One picture will fit better. Listen for the clue the sky will keep, and ask which story it chooses, in the end soon. Stand outside on a clear night and feel the cool air on your face. Above you, the sky hums at 2.725 degrees, above absolute zero, a quiet glow from first bright minutes. We ask a brave thing. Is that glow only our beginning, or a whisper from a world before? CCC turns wonder into tests we can point at the sky. If an old age really hands us shapes, not sizes, then soft rings, gentle low spots, or tiny twists in the light may rise above the noise. If they do not, the standard picture stands tall, no need for past aeons. Either way, we learn. We learn how time gets the arrow, how black holes fade, how light keeps memory when mass is gone. We learn to match bold ideas with careful maps and clean math. And we learn patience because the sky speaks in numbers and slow clues. New surveys will listen deeper, colder, and wider than before. If a true pattern appears, the story of our start will change in a single breath. Until then, keep looking up and wondering. If the universe is a relay of ages, what part of its baton do we already hold?